Good afternoon, everyone. I'm Chris Spinago from the Warning Decision Training Division. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from Villanova University. Our presenter is Amanda Wagner, who will be presenting on the relationships between storm mode, tornado warning outcomes, and social vulnerability. With all that being said, Amanda, the floor is yours, so go ahead and take it away.
All right, thanks, Chris. Okay, so thanks everyone for joining today. Like Chris said, my presentation is the relationships between storm mode, warning outcomes, and social vulnerability. But before we get into that, I just want to give some context of who I am. I got my bachelor's in meteorology at Virginia Tech and then came to WFO State College and was there for a couple years. And now I'm a graduate student at Villanova University. I worked with Dr. Stephen Strader on this project, and I just defended my thesis last week. So I am wrapping up and hope to be done and completed with everything and have the thesis uploaded to the internet very soon. So I want to start with prefacing that this project builds after Dr. Strader's work on the assessment of weather service, tornado risk, exposure, and vulnerability. He did this WTD Storm of the Month webinar back in 2021. So this QR code, if you scan that, it links to that YouTube video, or you can just look it up later. And want to begin with talking about why we're doing this. So storm mode, tornado warning outcomes, and social vulnerability have all been researched individually or in combinations of two of the variables, like between storm mode and warning outcomes, but no research has really looked at all the interconnections between those three variables. And this is really important because tornado impacts and tornado disasters are driven by combinations of all of these variables. So in this project, wanted to look at how they relate in space and time, and then how will this information be useful and helpful to weather service, emergency managers, public officials. So I'm going to talk about a little bit of background. I expect that this audience mostly knows what convective storm mode is and knows what a tornado warning is. So I will just touch on those, and I'll really focus more on the background of social vulnerability. So I want to talk about why I chose storm mode instead of what is storm mode. And storm mode creates unique challenges for forecasting and warning. Different storm modes are easier to warn for than others, and different storm modes occur in different regions and in different CWAs more frequently than others. And then there's also a social science component of it too. Like if a person is looking on the radar on their phone and they see a big storm coming towards them, are they going to think that that's a bigger threat than a small storm? For tornado warnings and tornado report outcomes, most people should know what a warning and report is. So I just want to define some terms that I'll mention later in this presentation. And this research, lead time warnings were tornado warnings with an associated tornado report and a positive lead time. So we did not include tornado warnings with 0 or negative lead times. False alarm warnings were warnings with no report. Hits are what we're going to call just the tornado reports that were associated with a warning, and missed events were those reports with no warning. And then to calculate climatological storm mode risk, we used a combination of those lead time warnings, false alarm warnings, and missed events. We didn't include hits in the storm event count because hits and lead time warnings overlap spatially and temporally. So we didn't want to double count those events. And this storm events measure looks at more than just tornadoes that occurred, but also storms that potentially could have produced tornadoes, like those false alarm warnings. So for social vulnerability, vulnerability is defined in many different ways. So it can be adaptive capacity, sensitivity, physical, it could be housing, socioeconomic. All these different factors could make people, individuals, community vulnerable to tornado hazards. This is typically measured with indices. In this study, we use the CDC's Social Vulnerability Index, but there are lots of different vulnerability indices out there that calculate vulnerability and risk. And this is important because tornado disasters and tornado impacts aren't just the strength of the tornado. It's also how well a community can cope and recover from these hazards too. In this study, we wanted to reframe the way we think about vulnerability in the context of warning forecasters. So what vulnerability variables would be more concerning in time before the tornado occurs, during the tornado, and after the tornado. And we really looked at before and after, maybe income, poverty, things that people are not able to make themselves more resilient would have a greater impact at those times than during the tornado. When during the tornado, warning forecasters are more concerned about how many people are under that warning, the type of housing and transportation, like mobile homes especially, what the language statistics are, so are people going to be able to understand and comprehend the warning that they have, and other factors like critical infrastructure, like nursing homes or hospitals, are really important in that time frame. For the meat of this project, after talking about a little bit of background, I'm going to go over some methods. So I took all new tornado warnings. We didn't include severe updates and tornado reports from 2007 to 2017 from the Iowa State Mesnet Archive. And we sorted those into categories, which were the lead time warnings, false alarm, missed events, and hits. And then for each of those warnings and reports, we classified the storm mode with machine learning, artificial intelligence, which I'll talk more about on the next slide. And then we did a vulnerability assessment using the CDC's SVI at the regional, CWA, and county levels. So talking a little bit more about how we classified storm mode with machine learning, our inputs for those warnings and reports, we use tornado warning centroids, so the center of the warning, and the tornado report lat longs at the initial issuance time for all of those points from 2007 to 2017. The radar images we used were from GridRad, and it's a radar image snapshot at the top and the bottom of the hour, centered at those points. So it looks something like this, where if you can see it, there's like a teeny tiny red star at the center of this image, and that would be that tornado warning centroid or tornado report and what the radar would look like at the top or the bottom of the hour closest to that issuance time. To train the machine learning model, I manually sorted 4,000 of these images into 5 basic categories, which I'll show you on the next slide. The model used decision trees and image classification, which if you are curious about this model, you can read my thesis after it's uploaded, or Dr. Alex Haberly at Northern Illinois and his graduate student Jeremy Corner just did a project on storm mode classification with machine learning. So Jeremy's thesis will be uploaded soon, and it provides a really in-depth overview of this model. After the model was trained, we ran the model on these storms and then tweaked and refined it, which is that validation and testing, and ran the model again and had an output of over 34,000 individual storms. So these were those broad categories, sorted into these categories based on past storm mode criteria and judgment of myself and my committee, we wanted to keep the categories really broad, just for simplicity's sake, and then use combinations of mode and convective coverage for like how much of the storm makes up that image. So discrete were isolated storms or several isolated storms. Linear were QLCSs, MCSs, squall lines, bow echoes, and linear included supercells embedded in lines. Multicellular were closely clustered cells or storms that weren't quite linear, weren't quite discrete. Tropical is pretty self-explanatory, and the other disorganized category were storms that didn't fit into any other category. For vulnerability, like I said, we used the CDC's SVI for each of these 4 themes, which are the different color blocks here. And each of these 16 variables, we ranked and compared them at the regional, CWA, and county level. So here's an example of the ranking and comparing between CWAs for socioeconomic variables. For the spatial context of this project, I looked at the storm mode, warning outcomes, and social vulnerability in 79 CWAs. We looked east of the Continental Divide, and then we had to cut off the bottom of Texas and Florida, New England, and the top of the U.S. because of radar data availability. We just didn't have radar data for those areas, so had to cut them off. And then we sorted those CWAs into different regions based on like climatology, different vulnerability variables, similarities in that aspect. So I'm going to skip the overall results just for the sake of time and really focus on one region in particular. If you read my thesis after it's uploaded, I go into every region and highlight those, but for the sake of time, today we're just going to talk about the Southern Plains, which includes the CWAs. So in the Southern Plains for storm mode, on the left here is the count of storm modes per CWA in the Southern Plains, and on the right is the percentage of mode per CWA in the Southern Plains. So OUN had the highest storm event frequency, followed by TSA and FWD. For percentage of mode in each CWA, it really varied. Most of the CWAs were predominantly discrete modes, except for Houston and Tulsa. And the highest percentage of tropical was in Houston, and most of those points were from Hurricane Harvey in 2017. When we look at this more detailed for seasonality and diurnal climatology, for seasonality, most of these storm events occurred in spring, and most of them were from discrete modes, followed by multicellular modes and linear modes. This region had a lot lower storm events in other seasons, but when we looked at other regions in the study, like the Southeast, this really changed. Looking at our diurnal climatology, most of the storms occurred in this afternoon-evening time frame, which was expected. But when we look at the percentage of storms each hour, most of those discrete storms in the afternoon, but overnight, we really see this increase in percentage of storm events for linear modes and tropical modes. For warning outcomes, this is just like broad, like a average over the 2007 to 2017 timeframe for warnings in this case. So light blue bars are those false alarm warnings, and the darker blue are the lead time warnings. So the greater the light blue bar, the higher the false alarm rate. And part of the reason why these false alarm rates were higher in other CWAs, which there are a lot of different factors on why they could be higher. One of the factors is storm mode. So for example, in the Houston CWA, they had a higher false alarm rate than the Amarillo CWA, and we could see that Houston had more linear modes and Amarillo had more discrete modes. For reports, similar patterns, if we look back and forth, where some of the highest false alarm rates were in EWX, HGX, MAF, and similar for reports. When we look at mode in the case of reports, in Dallas-Fort Worth, most of their reports came from discrete modes, but in Austin-San Antonio, most of them came from multicellular or linear modes. So shifting away from the storm mode and the warning outcomes, talk a little bit about vulnerability in the Southern Plains. And the Southern Plains has some big population centers, like in Dallas, Fort Worth, Austin, San Antonio, Houston. All these metro areas have a lot of people. But outside of those cities, there are a lot of rural vulnerabilities, particularly mobile manufactured homes. Like we see higher percentile rankings in the Midland CWA, in the western half of the Austin-San Antonio one, and out in the rural areas of Dallas-Fort Worth and Houston CWAs. At the CWA scale, it was really variable on which type of vulnerability you were looking at. So each CWA had something that they were vulnerable with in this case. So for age characteristics, it really varied. For percentile of crowding, which was households with more people than rooms, we really see this concentrated in our CWAs with those bigger cities. At the county level, same case where there's really variability between counties within CWAs. So we can't just look at vulnerability at the CWA level. We have to go more in depth and look at it at the county level to get a broader picture of vulnerability. To summarize all of these relationships, what are the relationships between storm mode, warning outcomes, and vulnerability in the Southern Plains? And it depends. It depends on what CWA you're looking at and what vulnerability variable you're looking at. So the most vulnerable CWAs in the Southern Plains, which were in the 90th percentile in many different vulnerability variables, were Midland, San Angelo, Lubbock, Amarillo, Austin, San Antonio, and Houston, but each CWA had different aspects of vulnerability. For storm modes, overall for the region, most of the storm events occurred in spring and were from discrete modes, but other types of storm modes occurred at all times of the year. For warning outcomes, again, it was variable, but those vulnerable CWAs like EWX, HGX, MAF tended to have the highest false alarm rates and percentage of missed events. So this creates unique challenges for each CWA in each region. The other regions I looked at, I just wanted to give like a quick snapshot of the regional overview, which my written thesis provides a lot more detail, but these were just those broad patterns. And while you all are reading this, I'm just going to talk about like how we can use this information. I think that this study provides a comprehensive tornado climatology. It doesn't just look at where or when tornadoes occur, but it also factors in storm mode and warning outcomes and vulnerability altogether. This information could be useful for training new forecasters coming into WFOs. It can provide some educational materials for people doing Skywarn spotter talks or any kind of public education, social media posts, etc. This information can also be used for future machine learning, AI, storm mode classification studies. especially as AI becomes more prevalent in the weather and climate enterprise. And this information can help us target vulnerable groups for outreach, education, mitigation, recovery, and resilience. And it really teaches us that we can't just look at broad regional overviews like this, which are nice, but local solutions are the priority and required. It really becomes a balance between, okay, like, for example, the Appalachian region has high vulnerability, but they don't see a lot of tornadoes. On the flip side, the Northern Plains has overall low vulnerability, very localized, but has a higher tornado risk. So what am I going to do next with all of this information? I hope I can keep giving presentations like this to people who are interested, maybe be involved in some IWTs, or if a WFO just wants me to give a presentation for them, I would love to do that. I'm also building this interactive story map where you can go and click on your CWA and it shows you all the statistics from this project. It's still in the works because I need to just make sure everything is updated and good to go. And you can also zoom in and it shows the county level too, which I think is pretty cool and an interactive way to show all this data. So my questions for you all, the audience, are, okay, so here's this information. Now what do we do? Where do we go from here? So if you have any ideas of how you would like to use this information, I would love to hear that feedback. And like if another grad student in the future were to expand upon this project, or if we could add more variables to this, what would be useful? And I can come back to this slide for the Q&A part if that would be useful, but I just want to give a thank you to everyone and open the floor to questions. This QR code has my contact information, and you can reach me at my school email here or my personal email. And that's all I have for you. So thank you.
All right, thank you, Amanda, for such a great presentation. Like Amanda said, if you have any information that you think would be useful in including these studies, feel free to reach out to her directly. Before we go, I'd just like to let you all know that we are still looking for a speaker for our July series. If you or someone you know may be interested, please reach out to either Chris or myself, and we can get you scheduled for that. Other than that, we look forward to speaking with you guys at the end of next month.